If you are watching this video, that means you have already tried learning DSA from big names, you name it. But let's be real, most of us still forgot those concepts after a week or a month. So after watching this video, I bet you won't need to watch any other tutorial because I have covered almost everything. You can check the code in my GitHub profile and don't forget to join the Telegram channel for more updates. So let's get into our video. Hello everyone, welcome back. And in this video we will learn how to detect cycle in a directed graph using DFS. So let's see today's insight. Today brought a bit of clarity. We should not blindly keep solving problems. Some concepts fade over time, not because we did not learn them, but because we never built the real intuition. We just followed default methods. Especially in topics like this graph. It's easy to forget concepts unless you truly understand the logic. So try to understand the intuition behind each problem. Why we are doing what we are doing. Let's start with this code example. So here in this case we have directed graph and we see a cycle here. So let's try to do a DFS traversal, and this is the adjacency list of this graph. So we'll start with node 1 and we'll mark this node 1 as visited. We'll move to node 2 and we'll mark this node 2 as visited. And from node 2 we have node 3. We'll move to node 3 and we'll mark this node 3 as visited. And from 3 we'll move to node 4 and we'll mark this 4 as visited. And from 4 we have node 1, which is connected node, and we see all the connected nodes for the node 4. All the nodes are visited. We see all these 4 concepts, detection of cycle and directed undergraph, all goes in the similar direction where all the nodes are visited, right? Even in the previous one we have seen the same thing. Let's try with another example where there is no cycle. Let's see what we can figure out from here. So we'll start with node 1 and we'll move to node 2. We'll mark this 1 as visited. We'll mark this 2 as visited. And from 2 we'll move to node 3. We'll mark this 3 as visited, and from 3 we don't have any nodes which are connected nodes. So this DFS call is completed here. Next we'll move to the another DFS call. We'll go to node 2 and we see this node is visited. And then we move to node 3 and node 3 is visited. So we'll start with node 4. From 4 we have node 1 and 3 as visited, and we see 1 and 3 are already visited. So even here we have got into a similar situation. All the nodes which are connected to node 4, all these are visited. Even in the case where there is no cycle present, we got similar situation as like in where there is a cycle present. So let's see what we can figure out from this. What's the difference that we can observe from this both the cases? So the only difference that we can see here is we have only one DFS call, and here we have two DFS calls. That's the only difference that we can observe here, right? So why can't we directly say that if you have more than one DFS call, then there is no cycle? So but this is not the case here. Imagine there is node 5 which is connected to this node 4. So in this case we have to call this 5 again, right? In this case we are getting 2 DFS calls. But what we have concluded that is if we have more than one DFS call, then there is no cycle. But here we can see a cycle with more than one DFS call. So this is not the actual intuition. So we are going in a wrong direction here. So let's try to go back and see how we can figure it out. Is there any difference that we can observe? So here the main reason why we are missing the point is here we have this node 1 and 3 as visited, but this 1 and 3 belongs to this DFS call and this 4 belongs to this DFS call. So this is the another observation that we can do here. If we can solve this issue anyhow here, then we have figured out our solution. So we'll simply use another vector where we'll mark these things. So we'll mark them and unmark them while we are doing the DFS call. So let's try to try it again. So we'll start with node 1 and we'll mark this node 1 as visited, and we'll mark it here also. And from 1 we'll move to node 2, we'll mark this node 2 as visited, and from 2 we'll move to node 3, we'll mark this node 3 as visited, here also we'll mark it, and then from 3 we don't have any connected nodes, so we'll backtrack to node 2. The case here is we are backtracking to node 2, that means we have completed this node 3, so we'll unmark this node 3. And from 2 we have only node 3 that is already visited, so we'll backtrack to node 1, we'll unmark this node 2, and from 1 we have only 2, and we'll backtrack to the for loop and we'll unmark this 1 here. And in the for loop we'll travel to node 2, we'll see this node 2 is visited, and then we'll move to node 3, node 3 is also visited, and then we'll start another DFS call starting with node 4. And for 4 we have node 1 and 3 as connected nodes, and we see that node 1 and 3 are already visited here. In the previous case we directly said there is a cycle present here, but here we have maintained another visited 2 vector so that we can ensure this case doesn't get wrong. We have this node 1 and 3 as visited, but in the visited 2 vector we don't have this 1 and 3 as visited. If it is a cycle, then we'll have this node 1 and 3 visited in this visited 2 vector also. Of course, right? Let's try for the first example. So we'll start with node 1, we'll have a visited 2 vector here, and we'll mark this node 1 as visited, node 1 as visited here, and we'll move to node 2 and we'll mark this node 2 as visited, and from 2 we'll move to node 3 and we'll mark this node 3 as visited, and from 3 we'll move to node 4, we'll mark this node 4 as visited, and for 4 we have only node 1 as connected node and we see that node 1 is already visited. We need to ensure that this node 1 is also visited in the visited 2 vector, and we see it is visited in the visited 2 vector. So that's how we figure out the cycle in this graph. So actually this visited vector 2 is ensuring that in which DFS call we are in. This is actually the DFS recursion vector. If we summarize this, we started with example 1 and we have seen that all the nodes are visited here, and then we have taken another example where there is no cycle and we have got into a similar situation, and then we figured out something like if we have more than one DFS call, then we said there is no cycle, and we have contradiction example for this where we have two DFS calls, but even then we have a cycle here. So then we got back to the previous case and we tried to see what's the main problem here. So node 1 and 3 are creating the edge case here. So we tried to store them differently in a different vector. We named that vector as visited 2 and we marked it in the visited 2 vector, and we have finally concluded that so for a directed graph to be cyclic, we need the nodes to be visited in both visited vector and as well as visited 2 vector. Only then we say there is a cycle. So let's try to write pseudocode for this. We'll call the function with adjacency list, visited vector 1 and visited vector 2 and the current index. So first we'll mark the current index as visited and visited vector of index equal to 1, and we'll also mark this as visited and visited vector 2, and then we call neighbors. So here we can have two cases. So first case, if it is not visited, and second case, it is visited in both v1 and v2. So if it is not visited, then we will directly call DFS for that neighbor. If this returns true, then we will return 1 saying that there is a cycle. In the second case, if it is visited in both v1 and v2, then we will directly say that there is a cycle and we will return 1. And at the end, if we are unable to get any cycle in these two cases, then we will return 0 at the end. We are missing something here. Before returning, we will unmark that in visited 2 vector. So that's it. That's how easy it is, and we have completed coding it.